Good morning, calculus students. Mr. Chen again. So today I would like to talk about the continuations of arc length and surface of revolutions. So this one is actually coming out from Rogawski, so 8.1 arc length and surface of revolution, and from the other textbook that comes out from 7.4. So suppose that you want to paint the surface of a vase. Okay, so let's say that we do have a vase like this. Okay, so it looks like this one. Okay, this one is not kind of artistic, so let me tell the one that it's better. Okay, so let's say that you want to make that the vase. So for the flower, and how much paint would you need? So we can use the area of a surface of revolution to help us answer this question by using the definition of area of surface revolution below. So record that going back to geometry. So the way to find out the surface area, actually the lateral area of this cylinder. So it's always considered 2 pi r times h. Okay, so finding the surface area, so which part of this area without the base, top and the bottom. So imagine that if that's a vase, so this one also, the cross section, those are just like a bunch of discs, circles. So in order to find out that the surface area, so we need to generate that 2 pi r, which is the circumference of the circle, and also times the arc length. Okay, and then once we multiply all those things together, we just want to generate that from A to B. Okay, so from A to B, so that's how we find out the surface area, the surface of revolutions. Okay, so we're that r of x, so that's the distance between the graph of f and the axis of revolution. Okay, so if x is g of y, so that means on the interval from C to D. Okay, so then we can generate that the surface area. Okay, so this one is doing that by horizontal. Again, the indicator, it's always perpendicular to the revolution axis. So let's say we do have a surface like this. So this one is perpendicular to that dx, and then the other one is just like a sideway. So that's like a sideway, so then that'll be going this way. Okay, so dy. Okay, so this one, it goes all the way from A to B. But this one here, it goes all the way from C to D. Okay, so now let's take a look at that one of the example. Find the area of the surface formed by revolving the graph of f of x to the power of 3. Okay, so that's the function. And the interval, it's 0 to 1 about the x-axis. Okay, so this one, let's just draw the graph. So x to the power of 3. So it's a cubic function. And this one's being bounded from 0 to 1. Okay, so dx. So this one is the shaded area. And the way to set things up, so it's going to be surface area, so 2 pi from 0 to 1. And r of x, so again, this one, r of x, just the radius right between the curve and the x-axis, the revolution axis. So there's no space or gap in between, so this one, we just use that r of x as x. And then, and for h of x, so that's just the arc length. So that one, it just considered 1 plus f prime of x. So f prime of x, which is 3x squared. So for the previous video, we talked about the way to find out the arc length. 3x squared, quantity squared. And then also multiply by the indicator, dx, the differential. Okay, so the way to integrate it, so we got 2 pi, integral from 0 to 1. So this one, it just considered the Pythagorean theorem. So square root of 1 plus 9x to the power of 4. dx. And then the rest of this you want to put into the calculator, because so far you don't have any kind of integration technique for doing this. Perhaps we can use substitution if you try to do it manually. So let's say u equals 1 plus 9x to the power 4. And then solve for x in terms of u. Okay, so you try to do it that way. So that means u minus 1 equals 9x to the power 4 divided by 9, both sides. And then 4 root of this whole quantity. Well, if you try to do it this way, then that's going to be more complicated. So try to use that u substitution, it won't work. Okay, so perhaps. So maybe this one we can use that the integration by part. Okay, so using integration by part, but also that's going to be making it more complicated. So normally this one is a calculator problem. So once you see things like that, so just plug in that to the calculator. So let me put it out. So for the TI, okay, so let's see what I got here for the TI 84 calculator. Okay, so going back to the problem here. So it's 2 pi times the integrals of from 0 to 1 x square root of 1 plus 9x to the power 4. Okay, so go to that. So x times square root of 1 plus 9x to the power 4. Okay, so that's just the integrand, and then second, back to the home screen, second quit, and then 2 pi times the integral, so math, 9 from 0 to 1, and then for the integrand, we just put in that to y1, so vars, y vars, y1, and then this one just multiply by dx, integrate it. So this one is about 5.91943, 5.91943. So just round it up to 5.919. Okay, and now here's another one. So now you want to try this, finding the surface area. So that is being formed by revolving the graph of x squared. Okay, so x squared. And this one is revolving around the y-axis. Okay, so this one is going around this one. Okay, so surface area. And let's see what else that we have. The interval is from 0 to root 2. So if this one is 0 to root 2, so we do know that dy, the indicator or the differential, it's always perpendicular to the revolution axis. So basically what we have to do, we need to switch this one, we need to solve for x in terms of y, so that means x equals root y. Okay, so square root both sides. Another thing that we need to be doing here is changing the boundary, because this one is just given the x value, x1, x2, or a and b, so change that to the y value. So we got 0 equals root y, so that means, well, y equals 0. And then the other one, root 2 equals root y, so that means y equals 2. Okay, so set it up. So 2 pi. Yeah, let me just get more space down here. So 2 pi. So this one is bounded from 0 to 2. And then radius, again, there's no space or gap in between that, the revolution axis, and the curve. So that's just y. And then square root of 1 plus f prime of y. So f prime of y, so this one, take the derivative, so we got 1/2. And then y to the power of negative 1/2 for that x prime. Okay, so 1/2 y to the power of negative 1/2 quantity square dy. So again, the rest of this we just put into the calculator. So y times square root of 1 plus 1/2. Well, this one just simplified it a little bit if you want. So it's 1 plus 1/2 quantity square 1/4 y to the power of negative 1/2, which is what? Y to the power of negative 1. So it's 1/4y. Okay, so checking the work, making sure that we put in things correctly. Okay, so this one again, integral from 0 to 2 times 2 pi, and then times the differential. So now let's put into the calculator. Whoops, back to the calculator mode right here. So we got 2 pi integral. So once again, math 9, and this one's being bounded from 0 to 2. Okay, so integrand. One thing that I forgot to do for the previous one. So besides, oh, you know what? That's right. y1, we put in the functions. Okay, x times square root of 1 plus 9x to the power 4. And now for this one, so I mean, you might want to be considered converting it to y, but you know what? Use y as x. So what we found here also, which is what? X. And it's a square root of 1 plus 1 over 4y, or 1 over 4x. Okay, like that. Okay, so making sure that we're setting up the integrand correctly. So checking the work right here. So y, again, we're using that as x. So x square root of 1 plus 1 over 4x. Okay, so integrate it. Again, back to the calculator. So 2 pi, 0 to 2, integral. And we want to put in vars, y vars, y1. This one will be y2. And then dx. Again, instead of converting it to x in terms of y, so we just want to use that y as x right here. So eventually you're going to end up with the exact same thing. So 13.988.6, 13.989. So this one is 13.989. Okay, so again, so one is that you have to integrate it with respect to x, the other one you have to integrate it with respect to y. So one is considered vertical, and the other one is considered horizontal. Okay, so thank you for watching the video today. So I'll see you guys next time.